Again, this is for Math 60, section 4.3, and this is our third video. So we're going to do two practice problems. I'm trying to go through this a little bit quickly so that I can get this under one video. Here's my system of equations. I'm going to look it over. I kind of like that. I got a negative here and a positive there. I got a positive. Ooh, lots of good stuff looking good. I think I'm going to go for the smaller numbers right here. And I can get that y to drop out if I multiply this first equation by 2. So that's what I'm going to do. So 2 times 7x is 14x minus 6y is equal to 8. And I'm going to copy this guy down. Negative 14x plus 6y is equal to negative 7. And I'm ready to add. Positive 14 and negative 14, whoa, that's a 0. And these guys are a 0. And over here, I get a 1. Well, 0 plus 0 is equal to 1. So in this problem, my variables all dropped out. And I ended up with a false statement. When that happens, these two lines have nothing in common. There is no solution to this system. And in fact, these guys are parallel lines. So I'm going to say no solution. Okay, so that was kind of interesting. Let's take a look at this guy over here. So I've got an x and a 3x, a 3y and a 9y. I don't see any difference in signs, but I think I'm going to work on this right here. And if I multiply that by a negative 3, then I can get this guy to drop out. So that's what I'm going to do, times a negative 3. So negative 3 times x is a negative 3x. Negative 3 times 3y is a negative 9y. And I get a negative 6 over here. Okay, I'm going to copy the other guy down. 3x plus 9y is equal to 6. And I'm ready to add. Whoa, again, these guys dropped out. And those added up to 0. And 0 plus 0 is 0. Okay. So the variables dropped out again, but this time I got a true statement, That means that there are infinitely many solutions. And if you think about it, this second guy is nothing more, the second equation is nothing more than a multiple of him. So these are really the same line. And if we were to graph them, they would fall right smack dab on top of each other. The other thing I want to point out to you back over here, if we wanted to take the time to isolate the y, I'm just going to do that just for a second. I'm going to do a lot in my head, so be patient with me. If I take, let's see, I'm going to work on this guy right here, right there. If I take this and I isolate the y, the 7x is going to come on the other side, so I get a negative 3y is equal to a negative 7x plus 4, and y is equal to 7 over 3x minus 4 over 3. Now I'm going to solve for y on this one also and see what happens. So I'm going to take this guy and put him on the other side, so I end up with 6y is equal to 14x minus 7. Divide everything by 6. I get 14 over 6. That reduces down to 7 over 3 minus, you know what, I didn't put the 6 over there, divided by 6, minus 7 over 3x minus 7 over 6. And look at what happened. This slope is the same as this slope. Well, we knew that ahead of time. This just confirmed it. These lines are, in fact, parallel to each other. So this is your three-step process. You more than likely get one solution for an ordered pair, so that meaning that these lines are probably going to, on your problems, they're probably going to cross each other in one place. If the variables drop out and you get a false statement, there's no solution. If the variables drop out and you get a true statement, there are infinitely many solutions. So I hope you enjoy using the addition method.